Understanding hypothesis testing is crucial for analyzing data and making informed decisions. Let's break it down. First, we start with the null hypothesis, H. This is our starting assumption, stating there's no effect or difference in what we're studying. For instance, if we're comparing test scores of two groups, the null hypothesis would say that the average scores are the same. Next, we have the alternative hypothesis, H or HA, which is what we're trying to prove. This hypothesis suggests there is a difference or an effect. In our test score example, the alternative hypothesis would claim that the average scores between the two groups are different. To determine whether we accept or reject the null hypothesis, we use the significance level, alpha, usually set at 0.05. This represents a 5% risk of rejecting the null hypothesis when it might actually be true. Then, we calculate a test statistic using our sample data. This could be a t-statistic, z-statistic, or another type depending on the data. The p-value comes next. It's the probability of obtaining results at least as extreme as what we observe, assuming the null hypothesis is true. If our p-value is less than the significance level, we reject the null hypothesis. Finally, the decision rule helps us make our conclusion. If the p-value is less than or equal to the significance level, we reject the null hypothesis, indicating evidence against it. If not, we fail to reject it, meaning we don't have enough evidence to prove a difference. And that's a quick overview of hypothesis testing, an essential tool for making data-driven conclusions.